Hello everyone. So in our last video we discussed about the gravitation, what is gravitation, how it can be measured, what was universal law of gravitation. Afterwards we have discussed how acceleration due to gravity we can calculate and what factors does it depend. And we also discussed how this value of small g gonna vary if we change its position or we just vary our position on earth, means we move to the poles or we move to the equator, how it's gonna vary. And we also discussed how the equations of motion changes when the object is in upward motion or downward motion. Now we're going to take the last topic of your term 1 physics portion, that is mass and weight. Now mass and weight, these two are quite related terms in some extent but not completely related. Mass is what? It is the actual quantity being contained in any body. So mass is basically total matter. Total matter present in any body is known as your mass, whereas weight is the force exerted on body due to gravitation, and due to gravity pull we can say. Now since mass is total matter, so its value remained constant throughout the universe. So we can say mass is always constant. No matter where you go, where you want to calculate, its value gonna remain the same. Whereas if we talk about the weight, since weight is force due to gravity, and we have discussed in our previous videos that how gravity can vary. So weight can also vary. So we can have variable values for weight for same body. For example, if you have certain body on planet Earth, you want to measure its weight, and let's say its weight is coming as 50 Newton. Then on Moon, we just want to weight again, that won't be giving 50 Newton this time. There will be a different value. Similarly, there can be a possibility and we can have zero weight as well. Can you think of a situation where we can have zero weight? Just think. Okay, the two possible scenarios I am putting forward in front of you. One is when you are falling freely in a, we call that lift. You are standing in the lift and the lift is falling freely. So in that situation, the weight of your body is said to be zero. And again, if you somehow manages to move to the center of the earth, then weight will be zero. Even if you go into the outer space where gravitational pull is minimum, then again the weight will be zero. So we can have zero values for weight, but we can never have mass as zero. If we say that how we measure them, so mass is measured in kilograms, the unit, whereas your weight is measured in Newton. Your Newton is your SI unit, but sometimes you also measure in kilogram force. Kilogram force is again the unit of weight only, right? So mass is measured in kilograms, whereas weight is measured in kilogram force. Now mass is a scalar quantity. So what do you mean by scalar quantity? That mass does not require any direction while you are denoting any body's mass, whereas your weight is a vector quantity, direction is there. And undoubtedly you must be aware that the direction of weight will always be pointing downward because it is because of the gravitational pull. So we want to calculate the total mass, we just put on the algebraic sum, whereas while calculating total weight we have to see how the bodies are being placed, or means what is the angle between them, and accordingly we can calculate the total weight being exerted. So this is about your mass and weight. That's the last topic for your term 1. Although in this chapter we are left with flotation also, but this flotation is coming in term 2 only. So we'll talk about flotation after your September exams, and later on we take flotation. Right now we just take on certain numericals based on your previous formula which we have discussed in this gravity chapter, if the object is moving upward or it's falling freely. So just have a closer look, because these numericals are the one which gonna help you to score good in physics. Theory part you can do, of course, you can learn, you can practice derivations, but when it comes to the application part, that is the numerical part, it is the one which is going to help you score good. Okay, so let's see. Let's take a first question. Okay, change the heading now. Let's write numericals. So here's your numericals now. So numericals, the very first one. Let's say we have an object whose mass is 5 kilogram. So a 5 kilogram object we are having, and this object is being thrown vertically upward with a velocity of 60 meter per second. Okay, an object of mass 5 kilogram is thrown vertically upward. This arrow is showing the upward motion. So object going vertically upward with a velocity of 60 meter per second. And you are supposed to calculate the maximum height this object will achieve and total time of flight. Now, total time of flight, what do we mean by this term? Total time of flight means for how long the object remained suspended in the air, for how long object was away from the ground. So these two things we have to calculate. Okay, now just see, we have been given mass, we have the initial velocity, we have to calculate height and time. Do we have acceleration here? You will say no, right? Because in the question the acceleration value is not given, but since the object is thrown vertically upward, so you should know acceleration gonna be minus g. Why minus g? Because the gravitational pull is pulling the object downward, but the object is going upward, so the force will try to pull it down. So we'll have a negative acceleration. Value of g, you all are well aware, that is minus 9.8. And while solving numericals, we can take it approximately 10. So we'll take g as minus 10 while solving this question. So see now, so u is 60, at highest point, what will be the velocity? Yes, it will be 0. So we'll have v equal to u minus gt. As discussed, that why we are placing minus sign here, because we are having a negative motion. V is 0, highest point, u is our 60, g is your minus 10. Sorry, since we placed minus already, so g is 10, and time we wish to calculate. Right? So after rearranging the terms, we'll get minus 60 here and minus 10t. This gives us t as 6 seconds. Now 6 seconds is the time the object has taken to reach the highest point. So 6 seconds it is taken to reach the highest point, so it will take again 6 seconds to come back to the ground. So total time will be 6 plus 6, that is 12 seconds. So this is your answer. And of course you can write total time of flight will equivalent to 6 plus 6 equal to 12 seconds. We are supposed to calculate the height, the maximum height attained. For that, which equation you can use? Since you have the time now, you can use the second equation as well as the third equation. Let's go with the second one this time. So S, here S we are talking about the height, so we can replace it with h. Ut plus half gt square, but since acceleration is negative, so ut minus half gt square. Ut is how much? U is your 60 and t we just got 6. So 60 into 6, that is 360. 360 minus half, g is your 10 and time is 6. 6 square will be 36. So 2 times 1, 2 times 5, this is 360, then 5 into 36. Just do the calculation. 5, 6, 30 and 5, 3, 15 and 3, 18. So 360 minus 18 gives us 180 meters. So this will be our maximum height attained by the object if it was thrown vertically upward with a velocity of 60 meter per second. Right? This was the case when the object is thrown vertically upward. The next question we'll take when the object has fallen freely from certain height. So look now. This time the object will be dropped. Let's say the object is dropped with the velocity of 0. What does this mean? This means the object is in free fall. And it's been dropped from the height of, let's say, 100 meters. Alright? And you're supposed to calculate the time it takes to reach the ground and velocity with which it will hit the ground. Alright? So what are you going to do now? We have the initial velocity. We have the distance has to be covered. Okay, again the acceleration value is not given. So now my question is to you, what will be the acceleration here? Now since object is free fall, so there will be plus g acting downward. Value of g was 9.8, approximately we can write it as 10. So a will be plus 10 meter per second square. So we have the distance, we have the initial velocity, we want to know the final velocity. Which equation you can use? The third one, so let's go with it. V square minus u square equal to 2gh. V is your, which to calculate, u is our 0, so minus 0 square will be 0 only, equivalent to 2 into 10 into h is how much? 100. Alright, so we get v square equal to 2 into 1000. Right? As if you want to calculate the value of v, so you just do the square root of it. So 1000 we can write it as 110, we can take it out. Inside we will replace with 2 into 10. This 10 can again be written as 5 into 2, so we can write it as v equivalent to 2 10 is already out. Inside we have 2 into 2 into 5. One more 2 comes out, we have 20 root 5 meter per second as the velocity with which it will hit the ground. We also want to calculate the time to reach the ground. We know the final velocity now, right? So time will be v is equal to u plus gt. T will be v minus u upon g. Now v is how much? V is 20 root 5. So 20 root 5 minus u, that is 0, upon g, that is 10. So this cancels out. So t will be 2 root 5 seconds. Right? This is another example where the object is falling freely. So these are two types of cases which can come in this gravitation part. The object thrown vertically upward or the object falling freely. Of course, there are more variety of questions as well, but for now we are stopping here. And our next class we will be taking just the numerical part from motion, force and gravitation. So you can have the numericals of little higher order thinking, so which is going to help you to have better understanding and better applications of the chapter.